Good afternoon, everyone. My name is Tien Nguyen, and today I'm gonna present the project WhoIs, working with my partner Ding Huan from San Diego. So let me start by restate the problem that we are working on. So as you know, today internet is filled with information, and so a lot of them are redundant and kind of hard to keep track of. So what we aim to is we want to extract the information in a normal form to a semantic form. Uh, for example, uh, when we look at a paragraph like Steve Jobs, the Apple Inc. chairman and co-founder, um, blah blah. We What we gonna care about is the entity in the paragraph. So here we care about Steve Jobs and Apple Inc. Um, so what we want to do is we want to extract the paragraph into three tuples. Um, for example, from this paragraph, we can extract it into the tuple Steve Jobs, Apple Inc. chairman, Steve Jobs, Apple Inc. co-founder. So the structure of these three tuple is first object, second object, and the relationship between the two objects. So in the scope of this project, we focus on three types of entities: people, organization, and location, and two types of relationship: people and organization, and people and location. Um, so the problem model, the input of the project gonna be raw text from online news. Right now we target all kind of news. Um, for example, the paragraph that I showed you before, Steve Jobs, the Apple Inc. chairman and co-founder, um, and the output gonna be a set of three tuples. Um, each tuple in the form of first object, second object, and the relationship. So yeah, it doesn't need to be human, organization, and relationship. It could be the other way around, like location, human, and relationship. Um, so the baseline, uh, well, uh, at the midpoint of the project, and presented in our midterm presentation, we already implement the baseline, which basically first take in a paragraph and identify the entity types in the paragraph. For example, this paragraph, Zinger's two largest investor is Chief Executive Mark Pincus, blah blah. So uh, with this paragraph, first we will run the NER Stanford library to identify the type of entities in this paragraph. So the output of this procedure gonna be an output with marked entity. For this paragraph, to be specific, we're gonna have organization for Zinger, person for Mark Pincus, organization for cleaner, Perkin, Caulfield, and Byers, um, and the other words is not marked because they are not fall into the three entities of interest. The second step is to extract the words between two entities, uh, because we believe that the relationship of the two entities are gonna be contained in the words between them. For example, here we see organization Zinger and person Mark Pincus. So the words between them, two largest investor and each chief executive, um, it actually reflect the relationship between these two entities. Um, so uh, we take out the words, remove the stop word, such as there's no stop word here, but those kind of words like the, and, is, or gonna be removed from the words. Um, so it would give us somehow the raw idea of the relationship. So we did that, and the result amazingly makes not much sense. So for example, um, yeah, for example, for this specific pair of entity, we're gonna have Zinger Mark Pincus, and the relationship is two largest investor, each chief executive. So well, that's not clearly a relationship. So because it has noise in it. So but at least we implement the baseline and we see the problems. So there's a lot of problems going around, but we just focus on three most interesting problems that we solve. Um, uh, so the first problem is removing noise in the relationship. Um, so here we can see that the noise here is two largest or is um, so uh, so the first proposed idea is to take only the noun in the set of these candidates. For example, two largest investor is chief executive. We're gonna take in only investor and chief executive. Um, so that somehow solve the problem. But then if we take a look at the second example, person Tien Nguyen sees a unicorn at organization Apple. If we also apply this method to take in only the noun, we're gonna have person Tien Nguyen, organization Apple, and unicorn, which makes no sense again. Um, so the final idea to solve this problem with noise in nouns is build a list of nouns that describe people only. So this list contain occupation such as doctor, clerk, title such as CEO, professor, and noun that created from verb such as worker, baker, and then we're gonna go over each single word in these candidates and match these words with the list of with the list of nouns that we created. So only matches word will be included into the relationship. Um, so the first problem we deal with nouns, and the second problem we deal with verb. So for example, this uh, this example again. Uh, Person Tien Nguyen sees a unicorn at organization Apple. Um, so the first idea also the same as how we deal with noun. We only take in the verb, and this doesn't make sense either, because see is not really reflect any relationship. So we build a list of human organization interacting verbs only, such as found, lead, hold, abandon, and then match the words and include them into the relationship. The third problem is false positive. So take a look at the first example that we saw. Um, well, yeah. Uh, so let me jump into the demo because it would take some time. So here we have a raw text which is extracted from some website. The label which is manually so we manually interpret those raw text and then create a label set, which is the correct set that will be compared to the result of our tool. And we're gonna run the tool against the raw text. Okay, it needs some time to load the classifier um, and interpret the result. So I'll go ahead with the third problem, the false positive. So the false positive is when we have extract a tuple and it's not really reflect the correct, like not really reflect the correct relationship. For example, here we have person Mark Pincus and organization Cleaner Perkins, um, and the relationship is venture capital firm. So for this false positive, uh, we um, we use the technology of search engine to filter the false positive. For example, if we have Mark Pincus, we have this tuple. We're gonna search, perform the search of this tuple on a search engine. For example, here. we're gonna use Google and put in the whole tuple here, and then we see the result. Um, so we build a script that crawl the first 20 result of Google and then try to apply our tool on those result again. And if we get the same tuple from those 20 results, that means the tuple will have a very high chance that is a correct tuple. Um, yeah. So now take a look at the result of the tool. So we can see it here, and we can see it in the output file. So output. So here's the output file, which is the result of running the tool against the raw text. And there's the label has 34 34 tuples, while the output has 27 27 results. So it's a pretty close result to the label. So we just keep solving one problem after solving the problems one after the other, and then improving the performance. Um, and so for the future work, I think we should keep solving more problems that derive from running the tool against real life data, which is from the online news. So thank you very much.